The next type of sensors we'll look at are PIR sensors, or passive infrared sensors. Now, I'm sure you've seen passive infrared sensors before, but probably not realized what they were or how they actually worked. Passive infrared sensors are passive, so they're not actually sending out any energy in the form of light or electromagnetic waves or anything like that. They're passive, they're just reading from the environment. And they're basically looking for detecting infrared radiation from objects. Now, everything that's at a temperature above absolute zero will generate some level of infrared radiation. This is the basis behind our thermal imaging that we looked at in previous lectures. And so some things will generate more thermal radiation than other things. Particularly, hot objects will generate more thermal radiation than colder objects. Now, what we have, as shown in the picture above, we have essentially two little parallel sensors. And as one of those sensors detects more thermal radiation than the other sensor, the small parallel sensors, we say that something's moved into the field of view of these sensors, and so we trigger our passive infrared sensor as a result of that. If both of these are detecting about the same amount of thermal radiation, well, then it's a steady state condition. But if we have movement within our room, which means that one of them will detect more than the other one, and that may only be for a split second, we can then trigger because we've got this discontinuity between them. Now, these passive infrared sensors typically only have two possible outputs, either a high or a low, based on whether they've detected something or whether they haven't detected something. And you can see here the little silicon sensors, which are sensitive to infrared light. Now, typically they have a little lens on them, like this lens here, which helps improve the field of view. And rather than being just a sensor that measures something directly in front of it, you can have a much wider field of view that can detect other objects within a room or within an environment that we're trying to measure. Now, these can have some false triggering conditions. Insects walking past them can trigger them, and changes in temperature, like if there's a heater or something is positioned nearby, or a draft, that can affect the measurements and cause false triggering with these. They have a fairly limited range, so typically 10 meters or so. Often material like glass can block infrared radiation fairly well. And so we get very little infrared radiation transmitted through glass. So if a burglar was trying to go into an area where it was guarded by a passive infrared sensor, if they held up a pane of glass between themselves and that passive infrared sensor, there's a good chance that they won't be detected behind it. However, if you've got a high source of infrared energy, a fire or something quite hot, that may still pass through that pane of glass, and some of it may be enough to trigger our passive infrared sensor or passive infrared detector. Now, I've already talked about some of the applications of these in security. There's lots of other applications as well. They use these in trail cameras to detect different animals walking past so they can take a photo. They use it in security lighting so that as someone's walking past, they can turn a light on so that they don't trip over and they see where they're going. And also probably to give them a bit of a fright and let them know that the area has some surveillance or something associated with it. And also within buildings, they use them for power saving so that lights aren't on if no one's in the room. The lights will turn off, and then people will walk around like this, randomly shaking their hands to try and make the lights turn back on because they've been still for too long in the room.